you need feedback to do real engineering, right? We're aggregating all this and that, and then we're pulling out one number, and then we're throwing it away, and then we're loading all 10,000 shifts, and we're iterating over all of them again. And just the most catastrophically wasteful behavior, because nobody was actually looking at what it was doing. They ask, well, how do I do this specific thing XYZ? And then somebody asks why, and you explain why, and they're like, that is not how you solve that problem at all. You need to step way back and think about this problem more clearly.
Tell me first, how did you start programming?
The very first thing that I ever did that you maybe would consider programming was actually making websites, because I'm young enough for that to be the case. But the way that I made them was my dad had like a GeoCities account, and we would just make web pages in Microsoft Word and then save as HTML, and then we would put them up online. And we like made a couple little websites that way. And that was initially magic to me, just because, you know, websites were this magic thing that I could visit to play games or to look at things, and now I can make my own. That was very cool. The first I'm sorry.
When was it?
I guess this would have been when I was probably about 10, so it would have been back in like 2005 or so. That's my recollection anyway. The first thing I did that was actually programming in any way was Lego robotics, I think. There was a Lego robotics demonstration at the Minnesota State Fair, and I think my mom basically just dropped me there for basically the whole afternoon. It was like, okay, Ben, go play with the robots. And I could have stayed there all week. You know, I loved playing with those. And that was like the very first Lego Mindstorms robot they had, the old yellow RCX brick. And it had some, I'm sure, very bad programming environment based on LabVIEW. But I just loved driving the bots around and making them do little things. And eventually then I got my own Lego robot kit, and I learned how to make websites better. And those two things were like the main programming activities in my childhood. At one point, I had heard that you could do this thing called JavaScript to do more interesting things on your websites. And so I went to the library and I got a book about JavaScript. And then I'm going through it, and it tells me to install Eclipse. I'm like, okay. And then it's saying, you know, okay, make a class and do public static void main string args. I'm like, okay. And then ints and doubles. I'm okay. And I'm like, man, when do I get to the website part? And you can probably imagine where I had gone wrong. But that was my first introduction to sort of native programming. And from there, who even knows? I did a lot of other little projects. I joined a high school robotics team, and then used all three of LabVIEW and then C++ and then Java on that team, and continued to make websites and continued to do JavaScript for those. And so I was always bouncing between different things.
If you would like to support this channel, you can become a member on Patreon. You will be granted access to a private Discord channel where you can chat with other supporters and guests of this show. For more details, check out my website at wooka.sh. Wookash. Nice. But then it means that you had already a lot of experience in various sort of groups. If you sort of start in a group, it's difficult to get out of this group, you know, like this mentality. I feel like I have not seen anyone who started in demo scene and like ended up in web development, you know, or vice versa, really. Like it's tricky to escape this sort of, because you already start to develop some sort of, you know, mentality, and like you kind of embrace the wisdom of the crowd from this within group. Nice. So robotics, a little bit of Java, and websites and web development at the same time. Nice. Did you go to university for computer science?
Yes, I did. It was the obvious choice because I knew that I liked programming a lot. And it was when I was in college that I was more than ever exposed to kind of the prevailing wisdom of the software industry. And it was the first time that I started to really seriously get a lot of advice that I found confusing about programming.
Like what?
Well, like all the classic object-oriented things about, oh, you definitely don't want to have a public field. You want to have a private field with a public getter and a public setter. And I'm like, okay, but it's clearly just a public field, right? Like, I can get and set it. And my professors would tell me, no, it's encapsulated. And I would say, it's clearly not encapsulated if it's equivalent to the public field. And that line of inquiry didn't really go anywhere. And there were many other things about the object-oriented education that I was getting that didn't sit right with me, that I found confusing. And at the end of the day, I still just really liked programming, and I was able to sort of make things work no matter what, and I was able to get the programs done, and I had a great time putting them together. But I would continue to have these frustrations and frictions of like, you're telling me something that seems straightforwardly nonsensical. Like, how can you possibly be saying this to me? It doesn't make sense on its face, you know? And I got a part-time job internship kind of thing at some point. And that was for a web dev company that eventually became the first company that I worked for out of college. And I would get some of the same kinds of advice from my coworkers there as well. You know, oh, you should refactor this thing so that it's more MVC or whatever, right? We use an MVC architecture in here, and so you should actually put this code here and that code here and have this code in the middle that translates from one to the other. And I would be like, okay, but what's a controller? And it'd be like, well, go read this blog post. And that blog post wouldn't really make any sense. I'd be like, I don't know, I guess, you know, these people are much more experienced than me. I will suspend my disbelief and go along with it, and hopefully it'll eventually make sense. It really didn't eventually make sense. And at some point during college, probably a couple years in, I don't really remember what came first, but I found the Handmade network community, and I saw Brian Will's video called Object-Oriented Programming is Bad. And I read Casey's semantic compression article, and I was watching Jonathan Blow's streams about Jai because I really liked the Witness. You can see Witness puzzles back on my wall.
Oh, nice.
Back there. And I couldn't tell you what order this all happened in, but it set off a lot of alarm bells in my head. I was like, oh, maybe this stuff doesn't actually make sense. You know, maybe there are people who actually know what they're talking about with programming who, you know, basically assurance that my questions weren't stupid or that it wasn't just a misunderstanding, but it was like, wow, all of those things that I thought didn't make sense, maybe they actually don't. And it just like, it was electrifying for me at that point in my programming career after, you know, a few years of getting more and more confused and disillusioned by the advice that I was getting. So that, and then, you know, I still finished up my college degree, and the later college classes were a lot more interesting anyway, regardless of what object-oriented things I might have been taught nonetheless. And I still, you know, I really enjoyed my discrete math class, my data structures class. There's a lot that I really value about it. And I went to a very small school, and I knew all the professors, and I had a very tight group of friends. It was wonderful. I've also come to conclude that my computer science education wasn't really uniquely bad. I mean, there's a lot that I would still criticize about it, but, you know, I still think I got a lot out of it, and it was a good experience and so on.
What language did you start with in the university?
Almost all of the classes were Java. There was a scientific computing class that was C++. And then I suppose the compilers class was also C++ because they were having us use Flex and Bison, which are, I think, GNU versions of Lex and Yak or something to that effect. You know, the classic lexer and parser generators. That is one of the classes I might criticize more, because knowing now how to make a simple recursive descent parser, it's like, oh, that's so much easier than what they were making us do in college. And not that thinking about it in terms of grammars is a bad idea. I enjoyed that part of my classes quite a lot, but generating parsers from grammars, I don't know. I'm not sold. I don't want to think about shift reduce conflicts. I just want to write a parser, you know.
Yeah. After university then, and you got into a job, and after working a couple of years, you gravitated towards the Handmade community, let's say,
yes.
right? So how did it look like, and what did you actually do?
Well, for many years, I was just a participant in the Handmade community, just lurking and discussing and contrasting what people were saying there against the things that I was doing at my job. And the entire Handmade network, Handmade community in general, was instrumental in my development as a programmer, just by providing grounding in all of the programming things that I was encountering in my job. And, you know, like, not everything that I was doing for my job was bad by any stretch. I mean, there were a lot of things that were bad, but I was fortunate at that job, because it was a pretty small company, to get a fair amount of ownership and responsibility nonetheless. I was able to some degree work on things that interested me, or at least to be able to take enough ownership of the things assigned to me that I was able to kind of make them my own and do them the way I wanted within reason. And of course, I have coworkers, and I would be interacting with them, and sometimes I would be able to, you know, bring something that was going on at work to the Handmade folks and say, like, am I crazy? Is what he's saying reasonable? Is he wrong? Is he right? Is he maybe wrong? Is he maybe right? You know, and sometimes just discussing problems and getting, you know, a voice of wisdom on it, because the way that I would be thinking about the problem is just totally wrong, as is so often the case when you're a young programmer. You know, I don't know if you've heard of the XY problem.
I feel like I've heard, but I can't summon now the definition.
Yeah, a classic example of it would be somebody comes onto a forum and asks, how do I get the last 3 letters of a file name? And then somebody answers that question, and then it turns out that that doesn't actually work, because the question they should have been asking was, how do I get the extension from a file? And it might not actually always be 3 letters long. The person asks question X when they should have asked question Y.
Okay.
And that kind of thing, I did that a lot. I think everybody does it a lot earlier in their career. You know, they ask, well, how do I do this specific thing XYZ? And then somebody asks why, and you explain why, and they're like, that is not how you solve that problem at all. You need to step way back and think about this problem more clearly. And I genuinely don't know where I would be as a programmer without all of the Handmade folks who sort of shaped my thinking in that way. Even just sitting in the same room as them, basically, and seeing lots of discussions about this or that really challenges the ideas that you might innately have, or especially that you would hear from the software industry. You know, they provide an amazing source of stability in your learning. So
we're talking about the Handmade community 10 years ago, roughly speaking, right? Like,
yep.
How did it operate back then? How did it look like?
Well, it was a Discord server, but small, you know. At the time that I joined, it was only 2 years into Handmade Hero's existence. And so Handmade Hero was still, of course, very active. And by that point, there were some web forums set up. There was a website that had been created by Abner Coimbray, Jeroen van Rijn, sorry for bad pronunciation of a Dutch name, and Andrew Chronister, who had put together then this website that could act as forums and sort of a center for the community. And by that time, there were also some projects that had been put up on the website, like Odin was up there as like a Handmade project, because Ginger Bill was like a day one member of the community. There was an operating system called Essence made by a guy named Noxt, and that was mind-blowing to me because I hadn't even really considered at the time. Like, I maybe knew in theory that you could make an operating system. You know, I had taken an operating systems class in college, or I was going to take one, but, you know, here just is an operating system, and it's it's got graphics and everything. It's so cool. You know, it blew my mind. And there was a Discord server by that point. I think it may have been relatively new because originally there was an IRC server, but then they moved people over to Discord eventually. And so, yeah, I just kind of joined this small Discord and hung out and watched all the discussions about all these different things. And over time, of course, it grew quite a lot. These days, the Discord has almost 9,000 people in it, and I'm sure that's over 10 times as many people as were there a decade ago, you know. And maybe if we clicked the prune button or the purge button in Discord settings, it would be down to maybe 5,000 or something. But
is there a button like that on Discord?
There is actually in Discord settings. You can press a button to clear out people who haven't interacted with the server in X amount of time.
Okay.
So if you want to ever just like purge your member list of all of the people who don't actually care, then get rid of that. But I haven't clicked it. I haven't wanted to click it. It's a public server anyway, so like, what's the point? But
okay.
But anyway, yeah, and it was definitely a much tighter knit community at the time, small enough to still have Discord channels that were like philosophy and religion and politics.
Oh, really?
Which was pretty spicy, but actually not a big deal when the main users of those channels are like Ginger Bill. So, you know, it was fun to sit and observe those things too.
So now you're leader of the Handmade network, right? So
yeah,
you're also in charge of the Discord?
Yeah, and there was an intermediate lead as well, actually, Ryan Fleury. Okay. Because originally, I think up until maybe, when was it? I guess it was probably about 2018. Abner was in charge of the community, and then he handed community leadership off to Ryan. And myself and Asaf Gartner were on the team as well, really just as like web people, because Abner knew that we were like web guys, you know, so we've got this website and we need web guys who can maintain it. So, and I had volunteered a bit before to beta test an educational series that people were trying to build. So people knew a little bit more who I was at that point and knew that I was interested in helping out. And so then they brought me on for that. And Ryan was lead for a few years. In that time, we started doing some of our jams and some of our other events. And it was a really wonderful time. And then eventually Ryan stepped down from that as well and handed it off to me, and I've been lead since.
So tell me now about how does it look like now in terms of jams, in terms of basically if you were to step back and imagine a young programmer who is also confused in university classes, and he's told about observer pattern and visitor pattern and a couple of factories and strategy and whatever, and would like to see some sense to it, and he hears about Handmade community and would like to understand what is it, what he can do there, he or she can do there, what's happening there, like a bit of like a pitch for the Handmade network. How does it look like now?
Yeah, well, right now you can visit the website handmade.network, and there you'll find a lot of the projects that people have made and posts that people have done. We have it integrated with the Discord, so if you go there, you can see all of the things that people have shared about their projects and that kind of thing. And the main hub of community, though, is the Discord that you can find linked on the site. And if you join the Discord, you'll find a programming Discord that has just general programming discussion, a help forum where you can get your questions answered about all kinds of different things. That's the main place that Martin's Mosaico hangs out, and so very good reason to join the Discord for that alone. We have topic channels about a variety of different things. Most people's favorite channel is our Project Showcase channel, where people can share images and videos of the work that they're doing and showing off their projects. Many people have told me that that's their favorite part, just because they find it so interesting and inspiring to see what people are working on. So, and as far as events, the main thing that we do is we run a couple jams every year, sort of like a game jam, but for programming in general. The flagship one that we do every year is the Wheel Reinvention Jam, which takes its name from episode 1 of Handmade Hero, because one of the very first questions that somebody ever asked on Handmade Hero, and I think it was literally in episode 1, was, why make a game without an engine? Why reinvent the wheel? And if you haven't seen that clip, you should go back and watch it, because Casey's answer about why reinvent the wheel is amazing. But we embrace reinventing the wheel, right? In the same way that Casey embraced it for Handmade Hero, for many reasons, right? I mean, first of all, it's just fun to reinvent the wheel. You cannot discount the fun factor of reinventing the wheel. But it's also crazy to think that what we have in the software industry today is deserving of being called a wheel. The field is so young, and so many programs, so much software is basically the first draft of something in that space, or maybe the second, but it's not like we've had enough time for these ideas to mature to the point where nobody can bring anything new to the table. That's crazy. And we should be excited about rewriting things or writing things from scratch and coming at old ideas with a new perspective, whether that's just because we have new hardware now or because we have new ideas about how we want it to work for us. So we do a yearly jam called the Wheel Reinvention Jam, where people can create whatever they want from scratch in a week, and it's a lot of fun.
Is it like a competition where you get prizes or something, or how does it work?
It's more chill than that. We aren't really strict about it, especially because it's very hard to enforce. Like from scratch can mean different things to different people. Some people have their own entire code base that they like to start out with, right? If somebody like Ryan Fleury or Alan Webster is going to participate in this, well, they've been building up the way that they like programming in C for a decade, and they're just going to bring that all in and start. Whereas somebody else might be starting with it's like their first time using Odin and they want to try it out, or they just want to use some other, we don't want to really be policing, oh, you're using Raylib. Is that really from scratch? So the main thing though is that we just ask that you kind of start on whatever your project is from scratch and see how much that you can achieve in a week. And we don't officially declare a winner, but we do like a recap show afterward where we pick out our favorites and bring the authors on to demo. So that's the main thing.
Okay, nice. And there are other jams, right? Other types of jams.
Yep. We usually do one other jam each year, and the topic for that one usually varies. That one's also usually a weekend, although I think this year we just did a week because it's like, whatever. If people only have the weekend to spend on it, they can just jam for the weekend, and that's okay. The jam that we did this year, we called the X-Ray Jam, because the theme was to look at how software works on the inside in some way. Like make tools to visualize some kind of like data in your computer, or like make something that dumps what's going on in your network stack, or make something that can like pick apart a file format and show you what the data is inside it, right? It's like point an X-ray at your software and learn more about what it's doing on the inside, right? The thinking being that that's a critical first step to reinventing the wheel later. If you're going to reinvent it well, then you should probably know how the current one is built. So, we do an early jam in the year where you can learn something, and then a later jam where you can put it to use. That's kind of the thinking.
Nice. Was there also a shipping jam at some point?
That was from an adjacent community made by a bunch of people who were around the Handmade space. But yeah, they had a particularly entrepreneurial bent to their group and just really wanted to try and put together... They wanted to encourage each other to ship more and to practice finishing things, because finishing software is genuinely a huge skill on its own. If you've never gone through the process of really trying to polish something up to ship, it's amazing how much work there is to do to get it from like a working demo, like a tool that works for your specific purposes, to a tool or product that anyone can use. And it's worth going through that process for sure, to practice it and to train yourself to understand how much work has to be done to make real software that is actually useful. But yeah, that was an adjacent thing, but I think a very cool thing as well. And there was some very fun software that came out of that.
Nice. And there's also a Handmade manifesto, right?
Yep.
Can you tell me a little bit about that?
The manifesto is an attempt to distill the values of Handmade Hero and the Handmade network in general, the Handmade ethos in general, into one document that gives people a sense of what we're about, right? The purpose of it is to clarify handmade values to the wider world. And it's gone through a few revisions because it's been a slippery thing to define over the years. And, the very first version focused a lot on performance, and then it led to a lot of people being like, software, Handmade is just all about not using libraries and making it really insanely fast. And it's like, well, kind of, but not exactly. And then there was an intermediate version that tried to shift some of that. So, it's been a little bit of a living document, but the purpose of it really is just to try and distill what the community is about, so that when people join, they know what it's about, And I think it's an important kind of thing to have. It's important to be able to articulate what your community values are in order to maintain those values over time. Certainly there have been a lot of discussions over the years of what does handmade mean, or isn't this handmade? Isn't that handmade? Isn't it handmade if I use this library, but I make it really fast anyway? Or no, it's not handmade because you used a library at all. It's only handmade if you write it from scratch. No, but you use this or that language. No, but that's too popular. Maybe it's not. It's very hard. Does it just mean low level? No, it doesn't really just mean low level, right? And so there's been so much of that over the years that I as lead have just had to try and, for a long time now, I've been trying to articulate what it is that sets the handmade ethos apart, and to defend it in some cases and to explain it in some cases. And the manifesto is just the result of that work.
Do you want to do like a hot take now, live on the Handmade manifesto? What is the Handmade ethos, or you want to point people to Handmade manifesto?
I would probably prefer to just point people to the Handmade manifesto.
All right.
But I don't know. I gotta review it so that I can. It might be, who knows? Maybe I need to edit it again. But the core of it, I don't know. I think the manifesto speaks pretty well for itself.
Okay.
It certainly speaks to what really motivates me personally, and I try to make sure that it's representative of both the original vision and value of Handmade Hero and the values of the larger community that sprung up around it, of people that were inspired by Handmade Hero. And the core things that it complains about are still super valid. The core attitudes that you see in the software industry that don't seem to care, they're still valid, So I still think that it says something really meaningful, and it's a community that I was so grateful to be a part of from the start, and I consider it a privilege to get to lead it now and try to keep it going and keep that sort of handmade flame alive, regardless of what else is going on.
Okay. So in terms of the future of Handmade Network, do you have some sort of plans or roadmap, or is it more like you're sort of like there are things happening and events happening, and you're accepting new people coming in that want to explore these, like, a realm of programming where people care a little bit more about what is happening underneath. What's the sort of the future, the outlook?
Well, the outlook is that we are now about 10 years into Handmade's existence. And over the past 10 years, a lot of the people who were initially inspired by Handmade Hero have gone on to become really great programmers and are at a point where they want to really do something meaningful with that. You know, in a sense, much of the community has grown up, and we see now a lot of people like Vyacheslav, for example, who are wanting to actually put out serious handmade software into the world and have it really make a difference in the software industry and redefine people's expectations about how software should be. And we have, for the past few years, been working behind the scenes to get a nonprofit set up. We finally, this year, got the determination from the IRS, so we are now officially
Nice.
a 501c6, and we can start doing donations and stuff. So we are currently in the process of putting together our plans for 2026, and I'm not yet ready to talk super publicly about what all those plans are. But now that we're at that threshold, and now that we've done the work to get that set up, we'd like to make the community, we'd like to transform the community into something that really has traction, and beyond just being a community, really does real work to support the development and publication and sustaining of handmade software. That's the main goal, and I'm excited to do a lot of work on that front in 2026.
Nice. All right. Awesome. Now turning a little bit into your work experience. You work now at Mozilla. We briefly discussed your job fresh out of college. That was web development-ish. Do we want to spend some time? Do you want to highlight some of the things that you worked before joining Mozilla? Some of the either lessons that you've learned or projects that you've worked on? Or we're going straight to Mozilla?
Well, I think it might be interesting to talk a little bit about the transition there, because I've really only worked 2 proper software jobs in my whole career. The first was that web dev company straight out of college, and I worked there for about 7 or 8 years. And when you include the years that I spent doing part-time and intern stuff while I was in college. And from there, I went straight to Mozilla and went from basically being a React and Go developer to being a compiler developer in C++. And that's kind of a crazy transition to make.
Yes.
You know, there's not really a lot of skill overlap between those, you wouldn't think anyway. And I do attribute the Handmade Network community to me being able to make that switch at all. You know, I wouldn't be able to jump straight from React dev to compiler dev without internalizing a lot of conversations over the years about how compilers are made and how low-level programming is done and how computers work and et cetera. And of course, I had my personal projects on the side too that bolstered that. But the things that I did at my last job that I think are the coolest or the most impactful were, in one I built a service for sending all of the company's email, push, and SMS, which was pretty high volume because the company made employee scheduling software. And so then every week, managers at different companies would push publish on their schedule, and employees would all get their schedule for the week. You know, oh, you're working at this location or that location. You're working this position or that position. And employees could trade their shifts with each other. And so there's a lot of notifications being sent around. And for a long time, the notifications were just an ad hoc mess. You know, it was all PHP code. And the funny thing about that is that you kind of want this notification code to be kind of a longer running process, especially because you have retry in there. You know, oh, the email didn't send this one time, or the push didn't send, and I need to wait a little bit and try again. So I need some kind of queue of messages that I'm working through. But the entire model of PHP is like, the server gets a request, it starts up the app from scratch, it runs it all, and it blows it away. Like that's the execution model of PHP. And so first of all, doing it in PHP was a bad idea in the first place, just because it's not fast, it doesn't garbage collect well, or it didn't at the time, and it's a disaster of a language anyway. But the whole app was written in PHP, so this is just how it was. And the push notification code was all ad hoc, and the SMS code was all ad hoc. Although perhaps better than what it used to be, because I heard that early on in the company's existence, their strategy for sending text messages was to literally have a closet full of Android phones that they just bought from like a normal store, and that they just set up with like a normal consumer phone account, and they just had a little Android app that would like take text messages from the database and fire them off over SMS. And eventually they got a call from T-Mobile or whoever, and they were like, what are you people doing? You can't be doing this on a consumer phone plan. So that was before my time, but then they replaced it with something else that was maybe similarly ad hoc, but used an actual SMS service. But the new system that we built was designed for retry and for reliable sending from the start, right? Messages didn't get lost because we had queues and we had backup queues. So if something failed to send, then we would retry enough times until we eventually concluded that the email was totally dead and gone or what have you. And it was all tuned for the kind of numbers we had right from the start. We wrote it in Go, which was nice because it could do a lot of the concurrency things efficiently enough, and without insane memory cost. We went from, I don't know how many instances of PHP running at once to handle all of this volume, down to just basically a couple Go servers because of redundancy that were just pulling jobs from these queues and blasting them out. And those things never fell over. They were so much more reliable, and it was fun to do the stress tests of like, how quickly can we blast emails through this system? How quickly can we blast text messages through this system? I have screen recordings on my phone of testing how quickly push notifications could come through. And the funny thing,
I've seen that, yeah.
Yeah, the funny thing is that Apple seems to not really rate limit you. And so you can fire a steady stream of push notifications at the rate of at least like 10 per second, and they'll just fly in on your phone, and they'll keep coming, and Apple just doesn't care. And it was crazy to me that we could do this, but the point was to test that the system wouldn't fall over under load, and it didn't. And that was a fun project, and one where I felt like we actually did real engineering instead of the ad hoc kind of, well, if it works, then ship it, and then you're trying to fix bugs later.
What were the parts of the real engineering then? How would you outline? Like, where would you put the line of like, here I'm coding for like whatever, like it works, bye, into like real engineering?
Basically just that we were actually measuring how many messages we were sending, and then trying to make sure that we could send at least that number of messages with some buffer, And we would do tests where we would like hit the system with 10,000 emails at once, or one where we would just drip them at a very fast rate, but over a longer period of time. And we actually, up to this point, we hadn't even really built any monitoring of, well, how many messages are we sending? Are they failing? I don't know. Maybe our support people can tell us if the emails are failing because customers are complaining, But like there wasn't very robust monitoring of that. But we actually went in there and monitored what we were sending, and then we tried to design a thing that would run fast enough to handle, 2 to 10 times that volume and make sure that it would still work okay. And we tried to make sure that it would handle all the rate limiting on the upstream services, and that was part of these tests where we would hit it with 10,000 at once, is what happens when you hit those rate limits. We got to make sure that the emails still go out, And that was really just it, is like, you need feedback to do real engineering, right? You can't really engineer without any measurement, right? And a lot of the time what you're doing is kind of, oh, I don't know, we need to build this screen, we need to build this feature, and so we're going to put this stuff in the database, and we're going to build this stuff on the front end, we're going to ship it, you know? And our QA people will tell us if it works, and if customers complain that there are bugs, then we'll fix the bugs. But, you know, you can do a lot of programming without doing engineering, I would say. You know, if you're not meaningfully tracking what the experience is like, then you get really bad results. And indeed, at that company, we did get really bad results from the parts of the app that we built that way. A lot of the work I did there was React performance stuff. I kind of shoehorned myself into that role because I was the only one who ever bothered to go to the performance tab in the Chrome DevTools and click record. And I'd be like, man, this is crazy. What are we doing here? Why are we, you know, I would like switch from 1 week to the next, and it would hitch for like 3 seconds, and I would look and I would just see the same massive stack of functions just repeated over and over again 100 times. And I'd be like, what are we doing? And it would turn out that, of course, we are like taking all 10,000 shifts that we've loaded from the API, and we're looping over all of them, and we're aggregating all of this and that, and then we're pulling out one number, and then we're throwing it away, and then we're loading all 10,000 shifts, and we're iterating over all of them again. And just the most catastrophically wasteful behavior, because nobody was actually looking at what it was doing. And there were some really stupid practices in that app. A lot of magical thinking about caches. Oh, we put a function around it that has cache in the name, so it'll be fast now because we're caching it, you know? And then if you actually look at what it's doing, it's very clear that it's not caching it. In fact, you're creating the cache on every call and then discarding the cache. So you are strictly doing more work than if you did not have the cache there. You are allocating memory that you are immediately garbage collecting. You're not caching anything, you know? It's... And people really just thought at that company that because, look, I put cache right there. I wrapped it in a function that says cache. So it's got to be fast.
But it's like when unless you measure something, unless you see it with your own eyes, you will never get any idea of what is really happening in the system. Yeah. And by the way, Chrome, I'm not sure whether Mozilla does as well, but there's, I think so, right? There's this profiling tools now that you have such a view of what is happening in your website, and trying to sort of kind of judge that based on the code, like this is impossible. And I wish like 50% of the best practices that are being thrown around with software engineering were be like, hey, look at the stuff that is happening, measure stuff, profile stuff, open it up, like walk through what is really happening, like ask yourself a question, is this going as expected? Is this doing the stuff that I think it's doing? Like, if this would be more real life, like instead of like methods should be 15 lines. It's like, brother, like come on, like return statements 6 at most. I'm like, come on.
Well, and importantly, I don't think that opening something up in the profiler is like hardcore performance engineering. It is literally just asking, is the code doing what I think it's doing? You know? And you mentioned that Firefox might have these tools now. I don't even just say this because I work there now. Firefox does genuinely have the best profiling tools in its class. The performance team at Mozilla has done an amazing job building this profiler that can show you both it can show you the JavaScript call stack and the entire native call stack for everything that's happening in the browser across all threads. You get all of the Firefox source code and symbols in the native stuff. So if you really want to know what it's doing, you can dig into that. Or you can just prune the native stuff and be left with just the JavaScript sort of graph. And it's very fast and very good, and I highly recommend it. And yeah, I use it all the time now. Whenever I'm developing anything, you know, I do the work and I get the result I want, and then I just click record on the profiler and I do it, and then I just see, hey, what's it actually doing here? Hey, wait a minute, why is this part so slow? the DOM sucks. That's why it's so slow. Like there's something there. Costs are never what you think they are until you measure them, and you also can very easily make mistakes that cause things to be done redundantly, right? I found a kind of overrun, like, a situation where I was over recursing and didn't realize it just by looking at the profile. And I was like, wow, that's way deeper than I thought it should be. And sure enough, I had a bug and I fixed the bug, and now it's a lot faster and it can handle bigger graphs, And that's not hardcore performance engineering. That's literally just, click record, do the thing. Does it look right? Probably. Move on. It's very easy. It's very close at hand, and people really should just do it.
And at some point, you sort of develop this intuition about what is expected to take, what time should it take. Like, hey, if it's a desktop software and you're reading a file, if you think like it takes 1 second today to read a file with like SSD, you are grossly mistaken, right? Like, but you
Yes.
were, I was this guy, but I needed to be like proven wrong when I opened up the provider and seen like super tiny blip, and this was reading a file, and another second it was just a mess that I've done. So
Yeah.
I needed to clean it up, and now I knew like this helps you to understand like what is going on and what is expected,
And that's one of the best things that the Handmade community did for me, was calibrating my expectations about what computers were capable of. And I wish that it had taken me farther at my first job, because I would sometimes say, hey, it's actually crazy that it takes 2 full seconds to load a schedule with 200 employees on it. Like, and we're doing a virtualized list even, so we're only showing like 20 of the employees out of the 200, and it's still taking this long. That's actually crazy. But I was a little too young for people to take that seriously. And I tried to do performance heroics to actually achieve what I knew should be possible, and usually didn't get there, and so I'm sure that didn't lend me a lot of credibility at the time. But at the same time, then you just look at what people are doing in the Handmade community, or like just the game space in general, where it's like, okay, I mean, here's a game with 200 guys on screen, and it's definitely taking less than 2 seconds per frame, like a lot less than 2 seconds per frame. So something has gone wrong somewhere, and maybe it's when you're using React, there's not a lot you can do. I've come to conclude frameworks can really get you very stuck in a certain performance category that you just can't really break out of. And there's just no way around it if you're going to stick with that framework, which is why you shouldn't use those frameworks. But sometimes your company makes these decisions, and that's what you got to stick with. But nonetheless, it was very valuable to have my expectations calibrated, so that, now when I look at a web app that I make and I see, that definitely took like a couple hundred milliseconds to do that. That's like really bad, actually. I know that it shouldn't take that long. What's going on? And sure enough, I always find something. Maybe not what I expect, but I always find something. It's very useful to calibrate your expectations that way.
All right. Let's turn to Mozilla now. You're joining
Yes.
Mozilla. Tell me a little bit about your work there.
Well, I'm on the WebAssembly team. So I've been at Mozilla for a bit over 3 years now. I still am relatively a beginner, actually, I would say. The SpiderMonkey team, because the SpiderMonkey engine encompasses both JavaScript and WebAssembly, there's a lot of people. I mean, I'm pretty sure I'm the youngest person on the whole team. There are at least a few people who have been there for well over 10 years, and SpiderMonkey is just the thing that they know backward and forward. And it's refreshing to work at a place like that where you're working with people who genuinely know their stuff. But yeah, at the time that I was hired, the WebAssembly team at Mozilla had reduced down to just a couple people, and it just wasn't enough to sustain the development of it. But a college friend of mine was the tech lead for the WebAssembly team, and so very fortunately through that connection then I was able to get an interview, and fortunately they hired me on despite me, as I have said, being really quite a beginner. I didn't have any career background in compilers. What I did have was some experience playing with WebAssembly and on just digging into it from a user level, trying to understand how it works. I had done a couple projects where I used WebAssembly without Emscripten, which, for those who are familiar, is like it's a way of getting C++ apps to run on the web without having to rewrite the whole thing. So it basically is compiling to WebAssembly and also emulating the C standard library and copying data back and forth between JavaScript and WebAssembly. It generates all the glue, and I didn't want to have all the glue. I wanted to actually use WebAssembly as it was. And so I was like handwriting that and reading the spec and learning how it worked. So coming into the interviews, I at least, sorry.
Can we spend a little bit of time to actually define what WebAssembly is, so that like everybody knows? I feel like this is so weirdly ephemeral that kind of people understand that it's kind of the recent quote from the interview, like it's WebAssembly, so it's not a web and not assembly. It's like
yeah. So a lot of to plainly say what it is a portable bytecode format for compilers to target that can be run on the web. It is something like LLVM IR or Java bytecode in its design, where it doesn't map exactly to CPU instructions, but it's designed to be something that can be efficiently compiled to machine instructions on whatever platform you're running it on. So a WebAssembly runtime, to work through the process, you might write some C or C++ or Rust code and compile it to WebAssembly, which is this intermediate bytecode format. And then you ship that in a browser instead of JavaScript, for example. And then the browser takes that WebAssembly bytecode and jits it to native machine code and executes that. So it achieves that kind of Java-style write once, run anywhere thing, and is designed to be an efficient... It's designed to be separate from Java or separate from any particular source programming language, right? It's supposed to be just this bytecode that anyone can target so that you can bring any programming language to the web instead of just being stuck with JavaScript. As you alluded to, the name WebAssembly is a bit of a misnomer, because the podcast that you're referencing said, it's not really web because it isn't only for the web, and it's not really assembly because it doesn't actually look anything like native assembly, but nonetheless it's called WebAssembly. And I've covered the part where it's not really assembly, right? It's a higher level bytecode. The part where it's not really the web is that it isn't actually tied into browsers in any particular way. In fact, a lot of the adoption of WebAssembly these days has been outside the browser, because it turns out that a lot of people appreciate having some kind of portable bytecode format that they can compile their code to. The other thing that WebAssembly provides is a WebAssembly module is sort of like a container in some ways. It is isolated from other execution in that it explicitly declares what it imports from the host, for example, a browser. It explicitly declares what it exports to the host. It can have like a memory associated with it so that it can have a buffer that it can do loads and stores into and have basically just a block of memory that it works on. But all of this is explicitly defined in the module. And a WebAssembly module, therefore, is kind of sandboxed by design. It can only interact with the host through its imports and its exports in these ways that you have control over. And this has actually led to a lot of adoption outside of browsers in spaces where you might have used containers before, actually. There are some companies who are using it to do some of their like cloud serverless kind of offerings where, you want to write some code that will run on our servers and it'll run, as part of our CDN. And instead of a container, which is basically a Linux process with like some file system stuff and permissions and C groups and so on, it's a completely user space thing that is sandboxed by virtue of being explicit about what it is allowed to access, instead of by just saying it's a process, but we're like masking away the file system and that kind of thing. And so it's seen some uptake there. And the thing that really did excite me initially about WebAssembly before I even started at Mozilla was that it seemed to be not so tied into the browser, actually. You know, it's this intermediate format where you can compile code and then you can run it on any platform. And the interesting thing is not that that's in a browser necessarily, it's that somebody actually did the work of achieving that write once, run anywhere kind of thing without it being tied to a specific language. That I thought was really exciting, because I think that's a good thing. I think that's something that's worth striving for. It's not necessarily good for every application, but, you know, clearly for most businesses, they don't actually want to write one app per platform, right? You see that all the time on the mobile side, for example. Like, so many companies move away from writing a native Android app and a native iOS app because they would rather maintain just one mobile app, and there's not enough difference between the platforms to make it worth maintaining both. So a lot of the time these days, that'll be like a React Native or web wrapper kind of thing. And in the past, there were other strategies, right? There were other like universal mobile app frameworks and that kind of thing. And they all kind of suck, but they do clearly achieve some kind of business goal, because they just don't want to maintain N applications for N platforms, you know? And the web itself has been very successful in that regard too. So that is, I suppose, a way in which WebAssembly is webby, but that's a thing that, if it's done well, I think you really want. The question is, of course, if it's done well.
The execution environment, which, for example, can be a browser, but in the other case of the other companies, like you mentioned, CDN, how difficult it is to create this execution environment from scratch if I would like to do it. And for example, is there a Microsoft one for Windows and like Linux Foundation for Linux, like that would be
like an actual runtime, an outside the browser runtime? Yeah, there are a few different options for outside the browser execution. To name just one, there's one called Wasmtime, which is made by a group called the Bytecode Alliance, and they're a group of people who have been involved in the creation of WebAssembly for a long time. And that is, I believe, one of the more common runtimes that they use at these like cloud companies, because it is a non-browser thing. It gives you access to native host functions. You know, you can load files, you can print to standard out, you can do the things that the web doesn't do, because the web doesn't have that model at all. But the most common use case for most people would be running it in a browser. And partially I think that's because the actual APIs that you would interact with on the host in the native case are not super well defined. The most you get is something called WASI, but WASI's not done. It's still, you know, in its like 0 point whatever stages. I hope I'm not misrepresenting it, but I'm pretty sure that it's like WASI 0.2 or 3 right now. And so it's still kind of early, and people are, you know, debating what exactly the interface is going to be for loading a file and that kind of thing. So it's not necessarily as mature in that regard. But on the web side, you can, albeit a bit indirectly, and this is maybe something you could talk about, but on the web side, you can do whatever JavaScript can do, albeit you might have to call back into JavaScript in order to do it. But you have all of the APIs of the browser available to you.
Okay.
One thing that frustrates a lot of people as they learn about WebAssembly, and this is something that, I mean, we could dig into like what WebAssembly should be in quite a lot of ways, but I do think something in the name WebAssembly kind of implies, it implicitly, I think, promises that you don't need JavaScript anymore, right?
Yeah.
That's kind of the premise, right? Oh, I don't have to write JavaScript anymore. I can write C, I can write Odin, I can write Zig, I can write Rust, I can write in my favorite language and ship it on the web, and I don't have to use JavaScript anymore. Unfortunately, the reality is today you totally still have to use JavaScript.
Okay.
And this is kind of sad. But the number one thing that people are sad about with WebAssembly is probably that you can't access the DOM. And to break that, I think it's worth breaking that down a little bit for people to understand where WebAssembly is actually situated today as a technology. Because the DOM, when people say the DOM, they're talking about the ability to create divs and images and, to create an HTML document dynamically from your code. That's what you have to do if you want to create a meaningful client-side web application, unless you're going to do all the rendering yourself somehow, but then you can't get text selection very easily, and you don't get browser extensions that can autofill the form fields and whatever. It's you want to be building up an HTML document if you want to ship a web app today. And the DOM APIs then are things like document.createElement. And so you can do document.createElement div, and that will create a div element. And then you can do mydiv.setAttribute class foo. And so then you can set the CSS classes that are going to be on that div. And you can set the inner HTML, and you can therefore include more tags inside of that tag. And you can build up your document, and then you can insert that div into your page. And this is what it looks like to build it up. It's kind of just a typical retained mode kind of API, right? The problem is that these APIs were designed for JavaScript. Something like document.createElement, well, there's no release element. There's no free element. It's just you create an element and then you insert it into the page, or you don't and you throw it away, and it gets garbage collected in some way, And a lot of the APIs are designed with sort of JavaScript isms in mind. I'm not sure that I have a specific example right now, but it's very common for a JavaScript API, for example, to have multiple quote-unquote function overloads, where you might have an optional second or third parameter that makes the function do something different if it's provided, because it's a dynamic language, and you can just do if arguments.length is greater than 2, do this, else do this, And so it's not, all this to say, there's not necessarily a very clean mapping from these APIs to any other language.
Okay.
And the lifecycle stuff is a big part of that, right? If the host is expecting that things are going to be garbage collected, but you're doing this from a language that isn't garbage collected, literally, how do you do that? You need some kind of handles. You probably do need some kind of explicit resource management. That doesn't really exist right now. And so how is a garbage collector or a cycle collector supposed to introspect into your app and say, okay, but which of these divs that you created are you actually using? Which ones can I collect? How are you going to do that? And because of that, there's no direct way. Well, and then also there's just things like strings. So WebAssembly has very limited types within it. To break down what the bytecode format looks like a little more, WebAssembly actually has functions in its format. It's not just like a big blob of machine code. You actually define functions, and you can export a function, and then you can call that function. The types that you can use for function parameters are generally very simple. They are like I32 and I64. And in fact, for a long time, those were basically the only types that you could have for parameters. And those aren't even signed or unsigned. They're basically just a 32-bit register or a 64-bit register, right? And then you have instructions that are i32.add, and then it will, add two i32s. Doesn't matter if it's signed or unsigned. They work the same. But you could do then, instructions that are much like what you would expect at the assembly level, right? You can do the signed comparison or unsigned comparison.
Ryan Fleury would love it.
I'm not sure that he would, but it is designed with. You can see from a design like that it is designed with the machine code in mind, right? It's not some really high level idea about types in a way that a programmer might typically think about, like an int type. It is. Oh, I guess that's why you would say he'd love it, because he has advocated for, I don't want signed versus unsigned. I just want i32. Well, it's true, actually. WebAssembly does just have i32 and i64. And you just do addition and subtraction and multiplication and division on it. And or no, division is signed, isn't it? Well, whatever. Multiplication is, no, whatever. Doesn't matter. So the way that this works, though, this works fine for like a native language, because you can have, if a string, if you're in C, is just a char star anyway. And so that's just going to be represented as an i32, assuming that you're using WASM in 32-bit pointer mode. And so a pointer is just an i32, an int is probably just an i32. You can do the like i32.load instruction I guess it would be, it's like i32.load8, for example. If you want to load like a specific char from a string, then it would just be go to this address in memory and load the byte that corresponds to that character, and that's all great. But if you import a JavaScript function and you want to call that JavaScript function, then how do you pass it a string?
Yeah.
That's the difficulty, because a JavaScript string is nothing like a C string.
Oh yeah.
In like any way. A C string is basically, assuming that you're just assuming we're just talking about ASCII and whatever, it's just a pointer to the start of the string data, and it's null terminated, and so that's it. On the JavaScript side, it is probably a UTF-16 string, and it's going to have an explicit length, and JavaScript strings get really fancy in engines, so depending on the state of the string, it might be some kind of rope data structure, or it might be some kind of flattened thing, and maybe they'll transition back and forth at different points, but it's this very fancy data structure that they have to make JavaScript string code run acceptably fast. What a JavaScript string definitely is not is just like a slice into your C memory. So if you're going to pass a string to element dot inner HTML, for example, if you're going to try and set the HTML contents of something, well, how are you actually going to get that string over into JavaScript land in order to call this JavaScript API? The API needs a JavaScript string, and there's like no way around it. So this is where you get into all the glue code that exists with WebAssembly today. If you want to call one of these, you basically have to have kind of a stub JavaScript function that you call, and you pass it a pointer into the WebAssembly memory, and then it can basically decode the contents of the WebAssembly memory and allocate a new JS string from that. And then it can call the browser API. And then whatever response it gets back, now it gets back a DOM element. Well, how do you pass that back to WebAssembly?
Okay.
Well, unfortunately, you probably can't, right? WebAssembly now has actually some types in its type system beyond i32 and i64. It has what are called reference types, and these are, for the sake of argument for now, I'll basically say that they are just kind of opaque values, and it's basically a handle as far as you're concerned in the WebAssembly code. So you might then pass your WebAssembly code a handle to some kind of host object, such as a div or something. But you can't store that into your WebAssembly memory, because the WebAssembly memory is just a big buffer of bytes. So you have to do something else on the side to store this kind of like opaque host value. And for most WASM programs, this boils down to having some kind of table of these references, and you have numeric indices into that table. And so you have this sort of translation from your reference value to a number that you can hand around your program, and then you can use that number to get the ref back and hand it back to JavaScript. It's not pretty. And the overall end result is that if you want to write some WebAssembly code today that calls web APIs, you are going to be going through JavaScript to do this translation of data between the WebAssembly world and the JavaScript world. And this is kind of sad. This makes me sad.
I feel like I have a little bit of inner conflict now, because like we started from this idea of like having a source language agnostic version of the sort of high level bytecode called the WebAssembly. And now we're talking about like all kinds of glue that need to happen that is also from JavaScript to map whatever you would have in your source language. So you're no longer independent of the language in this way, because like, oh, if your language has a C style strings, now you need to handle them differently while passing to JavaScript. And so it's like this illusion broke.
Yes. And you're absolutely right about that, of course. It is worth remembering that you always pay some of this cost whenever you're calling APIs defined by your platform, even in native development, right? Anybody who's done Win32 development knows that they sometimes need to pass a string in UTF-16 instead of UTF-8 or ASCII. Right.
Sometimes meaning all the goddamn time.
Yeah. Right. String. And that's frustrating, but it's also obviously true that there isn't one universal representation of strings. And yet, an API that wants a string, there's going to be APIs that need a string of text. Yeah. And that means that unless your language and the decisions you've made within that language happen to already perfectly align with the platform, you're going to be paying a cost whenever you do one of these calls. That's always going to be true whenever you have a boundary like that you're going to be interacting on. Now, that interaction wouldn't have to be JavaScript. That is like a particularly sad thing about it, because in the native development case, you obviously can just make, in a lot of cases, a temporary allocation and do your re-encoding, and then you just pass a pointer to that memory off to the host, and it does its thing, and it writes the result back into your memory, and you come back, and that's great. And that is kind of what's happening on the JavaScript side. But of course, on the JavaScript side, it literally is going to allocate a new string, and that string is going to have to be garbage collected, because it couldn't just pass a pointer to the original memory and operate on that. So it's worse, for sure, than what you have in like native development today. But it is to some extent an inherent problem. What I think is still very frustrating though for people is that you really do have to keep JavaScript in mind kind of all the time when you're making a real web application. Because even if you want to avoid the DOM entirely and just use like WebGL or WebGPU, you're still going to be calling into JavaScript to do that work. And a lot of the time, the translation cost between the WebAssembly world and the JavaScript world is high enough that you just don't really want to be crossing that boundary very much. And to be honest, that's probably also a little bit true of native development. But a lot of the time what people find is that, well, actually, unfortunately, the best use of WebAssembly for my application is I use it for the like really intensive compute part of my application. And then it's worth the cost of me copying over the big buffer of data. And then I can do all of my WASM SIMD code that does faster compute with no allocations, that I can't do any of this in JavaScript. And then I copy the result back out to JavaScript, and I have to, pay the cost of allocating all that again. It can definitely pay off when you have a workload like that, but you don't really want to be bouncing back and forth between two different languages all the time throughout your application,
Can you walk me through, you mentioned the OpenGL, if I would have like single OpenGL canvas element and do everything in there, apart from network communication, but actually that's also would be the case. So what I would need JavaScript for, this bridge for?
Well, assuming that you're going to use WebGL, for example, you are still going to be accessing WebGL through JavaScript. You can import a lot of those WebGL functions straight into WebAssembly and call them. And hey, if they have all numeric parameters, then maybe you don't even need to write your own intermediate stub function to do kind of the mapping across. Okay. But I should really look and see exactly how it looks to do something like a GL buffer data from WebAssembly, because or just here we're gonna deviate a little bit to MDN here and look for the buffer data method in WebGL, because let's see, what can the source data be? What can the source data be? A typed array or a data view that views an array buffer or shared array buffer that will be copied into the data store. Okay, I think actually that one would work with WebAssembly. For technical reasons that I don't really want to get into, you can create a JavaScript typed array that views the WebAssembly memory, and then you should be able to pass basically a pointer into that to WebGL, because WebGL is like, they basically just took OpenGL ES and ported it to JavaScript, and that's it. So it's a very native-brained API despite being a JavaScript API, if that makes sense, right? They don't use strings like static, dynamic, stream for their different params. They have enums, right? gl.static draw, gl.dynamic draw, So that all actually plays pretty nice with WebAssembly, because as long as you have numeric parameters, then there's no problem. You can pass numbers back and forth between JavaScript and WebAssembly just fine with very little cost. All the cost you pay is just a little bit of translating between different ABIs, because like the JavaScript world and the WebAssembly world might have slightly different calling conventions. But that's not that much of a cost compared to, I have to allocate and UTF-8 decode a string, and then I have to UTF-8 encode and write back a string, That's a lot more cost that you don't want to be paying on the regular.
All right, then. That's WASM, and all of this started from me rudely interrupting you while you were describing your project, when you said that you didn't want to use Emscripten, and I was already lost. Right. So can we go back to what's Emscripten? Yes. Is this the glue? And then to your project.
Yes. So Emscripten is the glue. Emscripten, so Clang can compile C++ to WebAssembly, no problem. That's a thing that's just built into Clang, and you can do that, and you can get a WebAssembly module. But if you use the C standard library, you're not going to have an implementation of that. And so you would be on the hook then to satisfy a lot of behaviors and a lot of imports from the host in order to make all of the C++ standard library work. And if you want to do a lot of interaction between JS and WebAssembly, right? If you want to pass strings back and forth, if you have a C++ function that has a standard string parameter and you want to call it from JavaScript with a JavaScript string, you're going to have that glue in between to translate between the two worlds. And Emscripten is a tool then that it wraps Clang and both uses it to compile your C++ and to generate all that glue so that you can actually run your C++ application on the web. And I mean, it's not pretty, but it does satisfy a business need for a lot of companies who have some kind of large C++ application. They want to bring it to the web because they don't want to be left behind as everybody's moving to, Chromebooks and what have you, and they're not going to be able to install their native thing anymore. So for a company like Adobe, for example, who wants to bring Photoshop to the web and who, as far as I can tell, doesn't employ anyone anymore who understands how Photoshop works, Emscripten is amazing, right? They can just throw Photoshop at Emscripten, it'll spit it out, it'll run, they've done the work to make the compatibility happen, and then they can slap whatever UI they got to on top of Photoshop in order to make it web native, you know? And for those businesses, it's great. But when I was starting out just as a hobbyist, before I was at Mozilla, I wanted to learn what WebAssembly was, and I instinctively recoiled from all of this Emscripten stuff, because it's just like, ooh, what is it doing? I don't understand. What's this glue that it's talking about? Why did it generate all this JavaScript that I don't understand? Ugh, I don't like it. And so I wanted to figure out how to do it myself. And there was an article that I found that explained how to just use Clang to compile from C to WebAssembly. And I was like, okay, that I can do, you know? And so I started playing around with that. And actually the original motivation was I wanted to try out a UI library called Micro UI by a guy named RXI, who's been in the Handmade community forever. He's an amazing programmer and he's got very minimal tastes. He is a wizard at writing the most incredibly simple code you can imagine. And in my experience, it doesn't necessarily do everything you want, but it will like shock you at what it can do in so few lines and without any tricks. It's just like he sees right through all the noise and just writes exactly the code he needs for precisely a certain situation. And he had this little UI library called Micro UI that works much like, it's the first occurrence of what I think is kind of a common pattern in UI design, or in UI library design now, where you have your UI code that produces a command buffer, and then you iterate the command buffer to actually draw the resulting UI. And so, for example, Micro UI had just a few draw commands. It basically had like draw rectangle, set clip rectangle, clear clip rectangle. Maybe it didn't even have clear, because it probably would just set clip rectangle again. And it could even do like depth ordering, because the command buffer was a big linked list. And after the whole UI was rendered, you could just do a sort and then sort of shuffle, like you could sort the list in place by just reordering some of the pointers in the linked list, so that as you iterated it, you would go through things in back to front order and you'd have your UI drawn out. And what I realized at the time was that, oh, interesting, it has just a rectangle command and a clip command and a text command and like a measure text function. And I think that the like browser canvas API, like not even WebGL, just the like canvas 2D, it's like this very beginner sort of you know UI library where it's like got draw line and draw sphere and or draw circle and draw arc. And I was like, oh, actually, but I could implement the Micro UI draw commands with that, and then I wouldn't have to do my own text rendering right now. I could actually just use the canvas to, you know, I could use the browser to render text for me and not have to worry about that. So my goal then was, I want to get Micro UI running on the web without using any Emscripten, without using any other libraries. I just want to go straight from a very simple C program with like no dependencies to that, and I want to see exactly what the connection is there. And that was a very valuable educational project for me. And it took some doing and really actually clarified a lot of things for me about how applications run. Like, for example, one of the things was like, oh, I need to provide, there's like a variable here that I need to import called heap base. Oh yeah, the heap would have to go somewhere, wouldn't it? I have to decide where the heap goes, don't I? Okay, I can do that. You know, I can decide where the heap is going to go. I can set up my own little allocator, or I can make sure the memory is this or that size, and I can do that. And oh, it needs to pass a string, Wait, so that means that when I'm getting a string back, like because the user pressed some key or they pasted some text, then I guess I need to like allocate on this side. Oh, but that means I need an allocator, and it like took me through a lot of that basic platform setup because I really had nothing, right? It was like WebAssembly strips away all of the host stuff and makes you like explicitly import it. But if you're not using the standard library and you're not, doing memory allocation via the host somehow, it's your job now. Have fun, And it was a great experience, and I did get it working eventually, but it took a lot of me writing little C programs and compiling them to WebAssembly and then doing the little disassembly thing because there's like a sort of text format. WebAssembly is a binary format, right, for size, but there's a corresponding disassembly sort of that you can look at. And so I'd write a little C program and then I would compile it and then I would disassemble it and I would like try to figure out what it was doing because I didn't know what the instructions were and I didn't know how control flow worked because it doesn't just have go-to, it has a structured construct, it's got structured control flow actually baked into it. And so I'm like trying to understand because I'd done Godbolt before and I kind of knew how that worked, but I was like trying to reverse engineer it. And so then I'm reading the spec. The spec is super confusing, and I beat my head against it for a while, but eventually pulled it together. And actually, that project became the base for one project that it's definitely not my finest work, but I made an application called regular.express, and you can go to that website if you want. And it's a visual regular expression builder where you can construct a regular expression not just by like typing the expression, but literally you can type out the characters you want, but then if you want to repeat something, you can just sort of draw a line back to like from the end of the thing back to the start of the thing. So you can kind of just draw a railroad diagram and build up a regular expression that way. And that whole thing is written in C, very bad C, but written in C and using WebAssembly and using micro UI to do its rendering. And
okay, so this is
what I came into my Mozilla interview with, basically. It's like, well, I haven't done compilers, but I have done this. So,
but you have done a lot of work already that predisposed you to all sorts of challenges that you're gonna face while you be in Mozilla. So I guess this would be probably even more. What's the word? Like more important for them generally. Like it's very WASM oriented, and you kind of show that you know this stack very deep because you've already done a lot of the work yourself there. Nice. That's awesome. Do you remember your interview? Yeah. Tell me how it looked like. Maybe like if you're worried that it's gonna be reused by Mozilla and you shouldn't share it.
I won't get that into it probably, except to say that I definitely felt like, oh man, there's a few of these questions that I really don't know the answer to, when they get into some of the technical specifics. But at the same time, everyone that I talked to throughout the course of my interviews, I think I ended up talking to them for at least 30 minutes beyond the end of the like scheduled interview time, because I was just like, oh, you did like WebRTC? Tell me about that. Oh, how did you do this or that thing? So I was just like so talkative about what it was like to work on a browser that I had some very fun, long conversations with the people who are now my coworkers about all different manner of browser development things. And in the end, I don't know, they decided to hire me. I feel very fortunate because, they definitely could have found somebody who had much more direct experience in that area. And, I'm very grateful for the opportunity to jump straight from web development to compiler development. And I was at a point where I needed to switch jobs anyway. I think I had basically learned what there was to learn from the last job. And moving to Mozilla has been a huge upgrade to it's been a huge jump in difficulty, but a huge motivator for learning and for practice and for just taking programming a lot more seriously in a lot of ways, because it just is way more challenging and it's way more fun than all the React stuff. Even though now, I will say I do sometimes miss having the really wonderful browser dev tools that can tell you everything about what's going on in your code, because now it's just, just today I put up my patch to CI and it's like, well, that works great, except that it seg faults, but only in the ARM simulation mode on Linux x86 machines. And I'm like, man, come on, don't do this to me. Why isn't our signal handler catching the seg fault that's supposed to? No, now I have to dig into, I have to figure out exactly what address it's seg faulting on and what actually emitted that code and what, it's like this very tedious, slow process. And we've got some great tools too. We've got RR, we've got our time travel debuggers, and that's all very cool. But, it's hard. It's definitely very challenging to debug some of the problems that I now encounter on a day-to-day basis. But, the funny thing for me is that for the last 2 years at least, I have continually felt like, okay, I'm still kind of green here, but I feel like I've got a handle on how the system works now. And I keep learning more and more about how the whole system works, and I'm able to, work more independently and change more of the code in more places with less assistance. But I still feel like I'm just barely competent. And, I still feel very green. I still am learning a lot from my colleagues. Since the very first day that I started at Mozilla, I've had a weekly meeting with one of my colleagues to just sort of chat about what we're working on and what I'm working on, and that sort of mentorship relationship has been amazing, and it continues to bear fruit 3 years in, because I'm not even close to understanding how it all works, and it's been very, very nice to have an environment that really fosters learning and challenges me like that.
Nice. I feel like this is common in the handmade circles, that people like challenge, but they sort of avoid this incidental complexity. You can make complex programs, but not because they solve complex problems, but they're just so convoluted and doing random things that you just stack layers and it's complex, but it's not necessarily challenging, right? And this sort of pursuit of challenge, I feel like is quite common.
Yeah. Well, and the nice thing about the complexity within the SpiderMonkey engine is, for the most part, it is, it's within the same order of magnitude as the essential complexity. It's it's not super over-engineered in the way that so much web software is. And I kind of just chalk it up to, over in the web world, the work is so inherently boring that programmers just actually can't take it. They have to over-engineer it in order to have a life worth living, And that you get so many crazy ideas there, because it's well, at the end of the day, my job is to read rows from the database and convert them into JSON, and to do the reverse. And that's really dull. I have to do something more interesting, and you get these crazy ideas. But compiling WebAssembly and compiling JavaScript and running JavaScript, and you have at least two different tiers of execution, because, that's a whole fun subject on its own. But suffice it to say that we actually have two WebAssembly compilers. One compiles very quickly but produces very stupid code, and the other compiles slowly but produces much more optimized code. Yeah. Because we want to both have very fast startup of web applications, but also for web applications to run quickly. And so we have to maintain two compilers, and all of the decoding and all of the validation and all of the runtime stuff. Now, because of some new features in WebAssembly, we have to integrate with the garbage collector in the engine. And so we have to play nice with that. We have to, if we want to add a new instruction to it, we have to write the routines that actually emit the actual machine code, and then we have to add it to our baseline compiler. That's the fast but stupid one. And we have to make sure that it can emit the code correctly there. And then for the optimizing one, we have to add a new type of node for the graph, and we have to add a new type of node for the register allocation, and we have to write the transformations between them. And there's so much that goes on in that. And there's not, I think, a ton of room for the like really insane design patterns, galaxy brain architecture stuff. There's just a lot of complexity as it is. And so there are some things in the SpiderMonkey code base that I'm sure a lot of Handmade types would scoff at. It doesn't bother me too much, I like what's a few smart pointers, basically. It's not really the end of the world. At the end of the day, it is still pretty much it's the right order of magnitude for complexity, and it's just an actually complex problem.
Would it be fair to say that your work is a little bit like chasing the spec of WASM to implement what is being added there?
It depends on how quick the spec is moving. The first couple years of my time at Mozilla were more focused on implementing new things that had been specified and that people wanted to start using. So one of the big ones was the WebAssembly GC proposal, which I alluded to, that adds a whole different execution model, kind of a whole different memory model, really, so that instead of having one big buffer of memory, you can actually allocate structs and arrays that are garbage collected. They are like managed by the host, and they are garbage collected. And this exists because that was what people decided was the best solution if you wanted garbage collected languages to target WebAssembly. Because there's actually some very nasty problems in there, which would be maybe interesting to get into, but they are also kind of tedious. But suffice it to say now, like if you compile Kotlin, for example, and you compile that to WebAssembly, that's going to use these new GC features. But that's a very large proposal, and it spent many years working through committee, and eventually it was standardized to a point where we needed to implement it. And so a lot of the first couple years that I spent here were implementing the GC proposal, making sure that it passed all of the tests and that we didn't have any crashes and security issues and so on. Fix all the bugs that our fuzzing team comes back with, and make sure that we handle all the weird edge cases around, wow, what if you export the function and then import it into a different WebAssembly module and then call it this particular way with a subtype of the original type? Does that crash? Does that do the right thing? There's all these very fussy edge case behaviors that you need to work through before you're fully implemented and can actually turn it on for everyone. Over the past year, it's been more of just a performance focus. The spec has been pretty much still after the GC thing was landed. And so we have really just been focusing on improving the performance of the WebAssembly engine, which has largely been a focus on improving the GC stuff, but there's other performance things that we do too. Some of that's just working in the optimizing compiler to try and do more clever things and to recognize patterns that we can optimize and optimize them. Some of it is fussing with the representation of objects within the engine, right? How do we store what is the actual memory layout of these GC structs and arrays? Can we store some of the memory inline in the object, or do we have to malloc a separate region for some of it? Do we have to, can we shrink that? Can we reduce the allocation costs? Can we so on? So there hasn't been a lot of user visible changes over the past year because it's mostly just been that performance work. But now next year we're looking at what is probably a little bit more exploratory work. And one of the fun things for me at Mozilla has been actually getting to participate in the committee, because I'd always just been on the outside and decisions come down from somewhere, and maybe you can lurk on a few GitHub discussions, but you don't really get to be in the room while it happens. Well, now I get to be in the room while it happens, and it's kind of fun. But funny enough, there's still a lot of room for WASM to improve. Frankly, I don't really like the whole GC design. I think it's a lot of complexity and kind of breaks from what I would consider the original vision of WebAssembly, at least in my mind. But there's still plenty of room to evolve it in other ways. And I am actually the champion of a proposal for better memory APIs, for example. If you talk to Handmade people, you'll hear a lot about like virtual memory arenas, for example, right? This is an allocation strategy that a lot of people like to use. Well, you can make an extremely large growing allocator if you simply reserve a lot of address space using your platform memory APIs, and then you just commit as you need it. And so then you have an absolutely massive range of contiguous addresses without actually taking any of the memory resources from the system, and it's beautiful because you've just got all this address space to play with. And that has not been at all true of WebAssembly because its memory design is so limited. And I remember, like, maybe just before I started at Mozilla, I hopped into one of Casey's streams. He was doing some kind of Q&A thing. And I said, hey, I'm actually going to be at Mozilla soon on the WebAssembly team, right? Like, I know that you've done some stuff with WebAssembly before. What's your, like, top three wishes for WebAssembly? And he said, well, they would definitely be memory, and memory. And he's basically, and he's right to critique it, because at the time, WebAssembly, you could only have 32-bit memories. You could only use 32-bit pointers. And therefore, you could only have like up to 4 gigabytes, and you have absolutely no virtual memory anything. You don't have any memory protection. You don't have any access to the underlying power of the virtual memory system on the host. It's just not there. And in fact, the lack of memory protection is very funny, because when I was building regular .express, I found myself very frequently making null pointer mistakes, where I would try to read from or write to null. But 0 is just a valid address in WebAssembly. Like, your address space goes from 0 to whatever, and it's all read-write. And so you can totally just write to null, and that just works. And I had to eventually build my own kind of null pointer exception system, where it's like, hey, it might not crash the app, but scream at me in the console. I just had some JavaScript code running like in a loop. It was like every frame, just check the first 4K of memory and scream at me if it's not 0, because I really need it to remain 0. That's not the best way to solve it, maybe, but I had to make that work. It is actually very limiting that WebAssembly memory doesn't give you access to any of these virtual memory capabilities. And I would really like it to support more of that. I mentioned that it could only do 32-bit pointers. That actually continues to be a misconception about WebAssembly. People will, on a recent podcast, I literally heard someone say, yeah, I mean, WebAssembly is pretty good, but for some reason they made the really strange decision. They only have 32-bit integers. And that, I don't know why they made that decision, but it really kind of sucks as a result. And that's like doubly wrong, because first of all, there have been 64-bit integers from the beginning. That's fine. But also now we have actually standardized and shipped 64-bit memories. Congratulations, you can use 64-bit pointers now. Except this is kind of useless to everyone, because when like game devs hear that, they're like, oh, thank goodness. Finally, I can do my virtual memory tricks. And the answer is, no, you absolutely cannot. First of all, you still don't have any virtual memory APIs. Second of all, browsers will still only give you 16 gigabytes of address space, period.
Yeah.
You can't get your, like terabytes and terabytes of address space like you would expect. You are stuck with 16 gigabytes, the end. We will not give you a memory larger than 16 gigabytes. And this is sad, but it actually follows from the lack of virtual memory, because if you ask the browser for a 16 gigabyte WebAssembly memory, that's going to be a 16 gigabyte memory commit, right? It's not going to be a reservation. It's a commit. It all has to be read-write. And so without exposing virtual memory capabilities, it's not actually sensible to ask for a really massive memory because there's a big difference between reserving and committing memory. Even on systems with overcommit, there's still a big difference between committing memory and reserving it. And like on Windows, if you just ask for 16 gigabytes of commit, you likely won't get it. Windows will likely, on a lot of consumer devices, just not give you that memory. Because Windows has a hard system commit limit that is basically 3 times the physical memory of the system. So if somebody's running this on a laptop with 4 gigs of memory, Windows is probably never going to commit more than 12 gigabytes globally across the entire system, every process running on the system. So if you just ask for 16 gigs of WebAssembly memory, it's probably going to say no, out of memory. So without actual virtual memory APIs, there's just not a lot that you can do, actually. And browsers choose to limit it to 16 gigabytes to sort of contain the damage, basically. It's just like, well, hey, we don't want people making web pages that just like ask for 64 gigs of memory or 128 gigs of memory, and it works fine on their dev machine and then crashes in all of these places, and then people blame the browser because it doesn't work in their browser, you know. So they're, they've limited it to what is unfortunately actually kind of a reasonable number given the semantics of WebAssembly memory today and the lack of any virtual memory capability at all.
I mean, it is technically sound and makes sense for these limitations, but then if you go back to the original vision, it's like, what about my game that I write in C++ and want to be there in the browser, right?
Absolutely. And that's, I think, the correct frame to have, right? If the promise of it is not really to have a bytecode format that is isolated in precisely these ways and that can run in browsers with these limitations. That's the implementation detail. The promise is you can write in whatever language, and you can also write more serious kinds of applications than you could before. And these are possible on the web now, right? Like, I think implicitly that's the promise of WebAssembly. And yeah, it doesn't really live up to that right now, which is kind of sad. So the funny thing is, so I've explored the virtual memory idea with people in committee. And it's actually a difficult space to navigate now because of how widespread the uses of WebAssembly are. I mentioned a couple ways that it's used. I think there's today, roughly speaking, 3 big ways that WebAssembly is used. One is for web applications. One is for kind of like cloud compute, serverless, like, web backend kind of work. And the other is for plugins. There are actually a lot of people who are using WebAssembly now for like games or databases or things where you want the user to be able to write some kind of plugin. I guess editors would be another good example, right? Where instead of, if you want people to be able to extend your system in some way and you want to allow them to write plugins, how are they going to write those plugins, right? Are you going to do like DLLs or something? Are you going to make them write it in Lua or JavaScript, right? Like some dynamic language, or Python maybe, right? A dynamic language that you can kind of like run inside your application. And so you've got like this little interpreter that's running this. WebAssembly actually can fit pretty nicely into those spaces because, first of all, it has wider toolchain support. There are a lot of languages that can compile to WebAssembly. And then because it's kind of isolated in a way that, because you can import whatever functionality you need from a host, it's actually not hard to say like, okay, import this plugin function and that plugin function and export this plugin function and that plugin function and, exactly fit whatever interface it is that you require. And if you want, you could even include a JIT, right? And you can include it there. But really only the web application case wants virtual memory out of those 3. There are actually reasons that you don't want to expose virtual memory APIs to user code in those other cases. From talking to the like platform as a service type of people or function as a service type of people, the entire advantage of using WebAssembly for them instead of like containers is that they can pack tons of these things into one process because they're isolated, they're sandboxed using entirely user space primitives, right? And execution within the WebAssembly module generally doesn't even do like a lot of syscalls then. It's like often just pretty isolated. It's just kind of this nice little box of userland compute that can't reach outside of itself in anything. So they can just pack tons of these into one process and get like really efficient utilization of their machines. And so they can, run these things at lower cost than if they were to do containers. But the computers that they actually run this on are, they've got gazillions of cores. And if you touch the page tables, it's bad. You get these really expensive IPIs, interprocessor interrupts that then like, okay, everybody, cache coherency time. We have to make sure that all of the cores are informed about all of the changes to the page tables and so on. So if you just allow like Joe random application to be like, yes, reserve for me all of this address space, thank you. Then like, bam, you are slamming all of the other applications on this. It's a really bad noisy neighbor problem. And so they don't want this. They don't want people running these like, I'm going to use tons of memory and I'm going to do all these virtual memory tricks. They're like, no, you're not. You're going to have like 8K of memory because we're not going to give you more than that. We've only got so much memory on this machine. You're supposed to be running this tiny little thing. You don't need that much memory. So they don't want it. They don't want the virtual memory stuff. And so that's like, that's sad actually, but it kind of does make sense. And the plugin case, a lot of the virtual memory implementation, in order to do it efficiently, you need to have some kind of signal handler installed. Right? When you like say that you're doing like some kind of memory protection thing, right? Say that was in these new virtual memory APIs for WebAssembly. And your WebAssembly code then tries to write to a string constant, and that's in a read-only part of memory. And so it generates a seg fault, right? Bad access. That has to get manifested. That has to not crash the whole process, right? That has to, in the plugin case, actually be handled as like a trap that occurred within plugin execution, and then it has to be like handled and then presented as an error back to the whole application. And a lot of people who are doing the plugin thing, they were like, I kind of just wanted my simple little bytecode interpreter. I'm not even shipping a JIT, right? I'm just like doing this little bytecode interpreter. And so now if I were to do this virtual stuff, now I have to install a global signal handler and make sure that I guess any bad accesses that happen in this range have to be like forwarded to this. And no, it's like so much to set up and it doesn't really jive with the plugin model that they're going for. And so they don't really want it either. And yet, of course, web apps are over here like, hello, I'm supposed to be able to ship a video game, and I can't ship a video game because I can't use more than 16 gigs of memory, and it all has to be rewrite all the time. And I can't even free any of it. I can't release any of it back to the operating system ever. This is trash. I can't ship a game like this. There's a GitHub issue from somebody at Unity that lays out a bunch of problems with that latter point, where it's like, hey, look, WebAssembly memory is like, you can only grow it, you can't shrink it, you can't ever free any of it. And so like somebody will be on the pause menu and the memory will be nice and small, and then they'll load a big level and we'll have to grow the memory to really big. And then they'll go back to the home, to the main menu again. And we like free all of this memory in, from our heap allocator. But the browser doesn't know that. We haven't released that memory back to the operating system at all. So from the operating system's perspective, it's still using all of that memory. And so we just never get to reduce the memory footprint on the system ever. And now when we run games on Android phones, the killer is just constantly killing these processes because it's like, oh my gosh, look how much memory they're using. And we're not using that much memory, but we can't tell the operating system that. And so we're getting killed. This is trash. We can't ship games on this platform. So memory is really... it's definitely very underbaked in WebAssembly right now. And because it doesn't seem to be as simple as, well, just ship mmap. right? Just ship mmap. Because it's not that simple, it ends up being actually a very difficult space to navigate. And I wish I have been able to spend more time on it over the past few years. I hope that I get to in 2026, because I think it's very important to the long-term success of it as a technology. But my personal opinion is that people in the committee have been overly focused on getting lots of languages to target WebAssembly and have really missed a lot of basic capabilities that people need to just build interesting applications in it at all. And I'm hoping that in 2026, that's where more of my work can take me, because I think that's what's really important for something like this to succeed.
This ties in to one of my questions. Every time when I hear committee, like, it's very sexy on tech Twitter to be like, oh, committee sucks. Yeah, we want benevolent dictators for life. And also these dictators should have exactly my version of this vision, you know? But like, this is cool. And I know that, like, so if you now are part of the process of how things are getting done in WASM, and this has this committee process, do you think it would be better if, for example, WASM would be split into these 3 categories, for example, or is the committee sort of effort at a good level compared to the lifetime of the WASM project? Or is it like committees kind of step in when the development slows down, right? Like, or they're kind of like inherent to this reduction?
Well, that is an interesting point, because it's definitely a case where it is being designed by a committee, right? And it's not really a case where somebody made a programming language and then they decided to standardize it after the fact. First of all, I think actually the WebAssembly committee is pretty good. It avoids what I would consider to be a lot of the pitfalls of other technical committees. Without saying any more, I think it's much better than the JavaScript committee, for example. And that's all I'll say about that. But the one of the things about WebAssembly as a concept, the promise of it is that you can write in basically any language and compile it to this shared bytecode. That even if it only ran in browsers and it wasn't useful anywhere else, you still would need, in order for it to be worthwhile, you still would need buy-in from all of the different tool chains and languages for all of these different ways that people program. I do not think that you can get that buy-in without some kind of committee process.
Okay.
You know, or at least I don't think that you can have it in a sustainable way, right? You could probably have, like, somebody just makes the really cool thing and then everybody wants to support the really cool thing. But if you want, like, major businesses to be targeting this thing and to be depending on it for, you know, these extremely lucrative enterprises that they run, well, they don't want to be basing all their technology on just one guy's stack. You know, they probably want to have a voice in it so that if they try to change the design in a way they don't like, that they can raise an objection. I don't think that's unreasonable. I also don't think that committees are particularly good at designing, but I think that if you want to achieve the high-level goals of WebAssembly, you have to play that political game somewhat. You have to include all of these different people in the conversation somehow. And they need to have some kind of voice in it, and they need to be able to say, well, if it's designed this or that way, it'll be very hard for us to implement, you know, with the semantics of our language or with the needs of our application. And so I think, in my opinion, some level of committee activity is necessary. And like I said, I actually think the WebAssembly committee does a pretty good job. I think that the people in it are honest about what they want and what they are trying to achieve. I think that the consensus process is effective. From my experience, like, decisions don't go through unless all of the objections to them are sufficiently resolved. But also, if one guy raises a really frivolous objection, the committee can just kind of move on anyway, and it doesn't have to be like a procedural nightmare, you know? And I would say that I think people have been, you know, I have observed people being what I would consider intellectually honest, right? That when they're faced with, like, well, the design that you presented is kind of crap. It has XYZ problems, or it doesn't actually achieve enough of a performance win to be worth the complexity or something. Or when someone suggests a better design that, you know, isn't the one that they made or that they wanted, well, they will admit as much, right? They'll be kind and honest and work with people to actually resolve the concerns of it. So as far as a design by committee process goes, well, I think actually it's not too bad. And it's something that I've enjoyed being a part of. I mean, that said, still moves slow, right? It's things don't develop quickly in an environment like this. If you really wanted to actually explore the space quickly, as I think you actually might want to in a lot of cases, you probably would want to just deviate from the community and say, like, well, I don't care what's in the spec. I'm going to try all my own crazy extensions to WebAssembly. I'm going to try this model. I'm going to try that model. I'm going to build this type of API. I'm going to change the control flow in this way. I'm going to add virtual memory APIs because who's going to stop me, you know? And you could explore the space a lot more. And I wish more people were doing that. There's a lot of potential for WebAssembly as a technology because it can be used in so many different ways. And a committee is definitely not a good way of exploring that space. I think the committee is doing a good job for what the committee should be doing. You know, it's doing what it should be doing, and it's doing a fine job of it. It is standardizing things and getting them stable and getting them to agree across browsers and across compilers, and doing the hard and tedious work of just getting everybody to agree enough that developers can actually use the technology. But I don't think it's good at exploring, and I wish that people were doing more to explore the space.
That's super interesting. It's actually, with WASM, you can actually do this exploration, right? You can write your own version that will handle it. Like, you don't need to depend on a browser.
Yep.
It's super interesting.
And the semantics are much easier than, like, the semantics of JavaScript, right? If you want to actually implement a full JavaScript engine, then that not only is that going to be a very large investment with a lot of complexity, there's all of the standard library, and there's all of the, like, promises and the, you know, all the other semantics of how things have to be handled. Whereas with WebAssembly, there is no standard library. There are just the semantics of the VM, and that's it. And there are reasonable subsets of it that you can choose if you want. If you don't want to do all the GC stuff, well, just don't do it. You know, you'll fail to compile any modules that try to use that feature, but oh well, just use a different programming language, right? If you use C or Odin or Zig or Rust, then you're not going to touch most of the new features at all, and so you can implement your own VM pretty easily that can absolutely run everything. I know multiple people in the Handmade community, like at least 3 people in the Handmade community who have done that, you know? It's actually a very tractable thing. And that's exciting because I think that it's worth exploring the possibilities of write once, run anywhere in a way that isn't tied to a specific language, you know?
Yeah.
I mean, I could pontificate about how this relates to operating systems for like a while because I think that what the web gives you is what operating systems should be, except it's implemented almost as badly as possible. So, you know, why shouldn't we be able to just type a URL into our computer, the name of an application basically, and just download and compile and run the application on the fly? And when I don't want it, I send it away. I don't need it anymore. And if you want to do that without being constrained to JavaScript and HTML and CSS, well, I think WebAssembly is one very important piece of that, right? Well, I don't want people constrained to a specific language, yet I want this to be able to work across different CPU architectures and different platforms. I want people to be able to implement this themselves for whatever type of device they have. How are you going to do that? I think WebAssembly is the cross-platform compute part of what I imagine operating systems ought to be. So that's a valuable thing on its own, and I remain excited actually about the possibilities that it has there, even though I haven't seen a lot of exploration of that. And of course, there's a lot more to building like the full operating system than that. And of course, you would have to extend WebAssembly and stretch it in a lot of different ways if it was actually going to have enough capability to do that, right? You still really can't ship a good video game on the web, and WebAssembly is a part of why you can't, you know? So I would like to see it evolve in that direction, because that's the kind of future that I think that we should have. And I'm excited to be, working on my little slice of that. But there's a lot more that could and should be explored, and you shouldn't wait on the committee to do it, for sure.
I like this hopeful vision of the WASM overtaking as a sort of primary runtime environment for the programs.
Well, yeah, I don't want to write JavaScript anymore. I don't. I want the future where I don't have to write it.
Also, it's nice that you would have not only the future where you don't need JavaScript, but your friend can do the JavaScript even though you don't want to, and you both can coexist in the same space, which is
absolutely
right now it's not the possibility.
Absolutely. I don't actually have anything against dynamic languages like inherently. If people, I will sometimes just write JavaScript for things because it's quick and easy and I can just get it done, right? Like, I understand the value of dynamic languages, but they can't be your only choice. They can't be. So we need something better, but yes, we should be able to let those things coexist. And of course, on operating systems today, they can. It's just like, it's an executable, or it's a script plus a runtime, or it's whatever. That can work. You can still have that. But we should be able to get like the actual distribution benefits of the web, the installation and the ease of use and the isolation by default, and all of these other things that allow us to just browse to some random website and just download and execute code without worrying too much that they're going to like hack and destroy us, right? Like, we don't have to do the like run as administrator, like, oh, are you sure you want to give this guy global access to literally everything? Like, no, we can actually have like more granular permissions than that. Or we can have, like an understanding of, well, this thing's sandboxed. It actually can't just randomly read what other stuff is happening. We should be able to have that and not be stuck with only JavaScript, only HTML, only CSS, right? There's no reason we couldn't, but it takes a lot to get there.
Nice. I think that's a perfect place to end with this hopeful vision. Ben, this was awesome. Thank you so much for the discussion.
Yeah, well, thank you for having me on.
You need to mention your social media and blog and your projects where people can find and follow your work.
Sure. My Twitter, my X is its_bvisness, because bvisness was taken and by somebody named Bernie D. Visness, and I wish I could contact Bernie to get it back, but for now it is its_bvisness. My website is bvisness.me, and I write blog posts every so often. And right now, I don't have any major projects in progress that I'm ready to share, although I'm working on something that I hope might eventually be. It sort of fits in with the like X-ray idea that I talked about way back at the beginning. But yeah, most of my time is spent programming for work and doing things with Handmade and doing things with robotics and a little bit of programming on the side. I'm hoping that in the coming year I'll be able to do more serious project stuff. But for now, it's just follow me on Twitter, follow my blog, join the Handmade Network Discord maybe.
Nice. Awesome. Ben, thank you so much.
Yeah, thank you.